Okay. So, hi, I'm Salim Lakhani. I'm the co-founder, CTO of DevPanel, and we've been implementing serverless Drupal for many of our clients. So, I'm here to talk about that with Joel from Voice of America. I'm going to turn it over to Joel. Joel.
All right, as Salim said, I'm Joel Lehman. I'm a solutions architect for Voice of America. And what we do, we're a media agency. We provide news and information. We've got an weekly audience of about 280 million people. We have web, mobile, and digital presence along with radio and television. We host sites in 47 different languages. And these are heavily trafficked sites. Our main site gets up to about 600 million hits per month. All told, we're rolling about 1 to 2 billion hits per month. So we're always trying to keep sort of ahead of our hosting, our website infrastructure, everything like that. And we had some experience with running serverless applications, and we said, thought, what if we could run Drupal serverless? Would it reduce our maintenance needs? Could it help with deployments? Would it scale to handle all the loads? Most importantly, would it reduce our budget? And government always in the back of our mind. Would it improve security? And so we decided to go through phase, develop a proof of concept, pick out our architecture, and then actually create a prototype. And through this process, we hooked up with Salim and DevPanel and his crew. And this presentation is a little bit about our approach and the results.
So I'm gonna jump in over here. So there's different types of serverless. One is serving your static website through S3 and a CDN, content delivery network, and that's a serverless site. And this presentation is not about that. This presentation is more about taking your entire Drupal stack with all the moving parts and making that serverless. So just to make that clear, it's not about serving out static sites, it's about taking your entire Drupal stack and making that serverless. And when we're talking about serverless, you'll hear things like event-driven computing, function as a service, and microservices. These are all terms that are thrown around, and they all fall under the heading of, dynamic allocation of services. So this is what serverless kind of falls in the category with all these things. So Joel?
And when we were looking at serverless, some of the things we really liked, it was a flexible cloud native. You're dealing with applications. You're paying the vendor to provide a platform for you to run code. You don't have to maintain machines. It takes a lot of the problems of doing that out. You're charged for what you use, which is really nice. For you don't want to have servers sitting idle and you're paying for them. And in doing so, it's scalable on demand. And then you think about sort of the functions as a service and the microservices and their impact on speed of development and deployment. And if you're not worrying about having the correct libraries on the server, if you're not worrying about doing OS updates to the server, it really speeds up your development. You let your developers code and then just deploy to the platform. But serverless isn't magic. It's running on servers, and there's always additional resources required. You have managed databases in the back end, networking, storage, authentication. But the great part is you're shielded from that.
And I just want to pitch in here. So serverless does use servers, but from our perspective, from the user's perspective, it's serverless because you're not managing any of those servers. So somebody else is. So that's from our perspective, that's serverless. Okay. So I just want to make that clear because people kind of confuse that at times. It's like, well, who's running this stuff? So yeah, there are servers involved, but as far as you're concerned, you're not managing any of it. Okay, so the path to serverless, from a hosting perspective, from website perspective, traditional hosting architecture. This is how the stacks are run. This is how Drupal has been run for years. You've got servers, a dedicated server or a shared server, and each one of those has the whole stack running from Linux to the web server, database, PHP, and everything in there. The problem with this traditional hosting approach is that it creates a single point of failure. There's non-redundant services, and there's inability to scale on demand, and it's essentially difficult to duplicate for development and testing and stuff. What you're doing is you're managing everything on one server, on individual servers. So if there's a problem on any of the servers, you have to log into each server individually and fix it. If there's an upgrade or if there's a patch, you have to go into every single server and manage that. So it becomes very cumbersome. After that came cloud hosting. And then in cloud hosting, the popular thing was setting up clusters and high availability environments because it was very easy to set up. And you'd have, this is back from 2013. I got this architecture from a screenshot from an article on the internet. And this is still valid. There's your load balancer. Behind that, you've got a few servers, and this is a cluster of servers. You've got RDS, which is your database, S3 bucket for files, and an email notification service. Everything is valid. This is a high availability cloud hosting architecture. And then nowadays, what's popular is this high availability fault tolerant architecture. And this, we put a link in here. This you can actually spin up. There's a one-click quick start for this on Amazon, and it's high availability, fault tolerant, runs on multiple availability zones. It's got a load balancer, uses Apache EC2 host. These are actual servers. Running a database cluster, but again, it's bottom line, it's server based, and you have to access it through the Bastion host, and you have to manage servers. That's the bottom line for this thing. So after that, if you by the way, if you want to do that, you can try and set this up, and you'll see it's not easy to manage, and it's not it's pretty cumbersome. So have a crack at it.
Good for one site, but if you're talking about many sites, it gets to be a nightmare.
Yeah. So enter containers. They're lightweight than virtual machines, a completely different architecture. They're portable, scalable, secure, fast, consistent, OS operating system independent, easy to replicate, deploy, roll back. They work well together. They network well together, so you can deploy them together. They're much easier to manage. There's different kinds of containers. The problem with containers is when you're deploying a bunch of containers, orchestrating the containers becomes hard. So you need an orchestration engine to manage clusters of containers. And there were different types of orchestration engines. There used to be Docker Swarm. I don't know if that's still around, but you haven't used that for forever. The king of orchestration engines today is Kubernetes. And there's different versions of that, like managed versions of Kubernetes. From Microsoft, you can get Microsoft Azure. Amazon has EKS, that's their Elastic Kubernetes service. Red Hat has their OpenShift. But Kubernetes can be used to maintain a declared state of infrastructure. That means you can tell Kubernetes you want 10 containers of a particular type running, and if a container dies, there's a problem. It'll kill that container and it'll respawn it. So, or if there's a problem or something, it'll monitor its health, cluster's health. So it will manage that cluster for you. It'll maintain those containers for you. It'll manage the load. So if you want to set up auto scaling, it will actually add more containers, or we call it pods. It'll auto scale them up and down for you, and it'll provision resources as needed. So if you run out of the servers, underlying servers where those pods need to run, where the containers need to run, it can actually go out to Amazon and get, for example, your provider, and get additional servers to run those containers. And then when you don't need those containers, it'll release those servers. So those are things that you can do with, that's how Kubernetes manages your infrastructure. And it handles all the networking, security services, and scaling. So we use Kubernetes. You can use Kubernetes to actually create a whole serverless environment. You still need services, and those are things that your platform provider like AWS or even Azure, those things, they'll provide managed services like the managed database and things like that. So you get those managed services from them to create a serverless environment. Okay, so now you have a serverless environment, but then, so what, right? So what difference does serverless make, right? So now I'm going to turn this over to Joel and have him talk about how they took advantage of the serverless environment.
So what we wanted to do, what we were looking at, as I said earlier, we have the managed cloud-hosted Drupals, high traffic Drupal websites, the huge peak loads. We have bi-weekly code releases, and all of our sites had the same essential code base. So we would be, any code release could impact 50. It was going to impact about 50 sites. If you could include UAT, which we needed, you're talking about 100 sites. So we also had a lot of custom Drupal modules. So the code releases were kind of a big event. And a lot of the sites had some larger databases, not huge, but around the 20 gigabyte size. So you're talking about being able to back up your databases and provide all that. So we were then talking about what did we expect when going through this proof of concept. We, of course, first and foremost, we wanted to reduce our expenditure. Budgets can get tight, and we wanted to provide as functional of a platform for the least amount of money possible. It had to be highly performant. We weren't willing to give up performance. Had to be on par with what we were seeing, if not better. We were a pretty small team, and going hand in hand with reducing the budget, we had to be able to maintain this with a small team. Like I said, we had a lot of custom modules. So the blue-green, immutable blue-green deployments were essential. We did extensive UAT testing, but if something did impact a site, it was going to most likely impact all 50 sites, and we need to be able to roll back quickly and transparently to the end user. We wanted to be able to do A/B testing. There's a lot, test new themes, test new looks, test new feels to a certain select portion of the audience. That was not easy to do in the current environment. And then once again, with government, we had a requirement for dev and UAT environments to go along with every production environment. So we're looking at like 150 potential websites. And the dev and UAT sites, they're only used a couple times really a week, or within 2 weeks for our deployment schedules. So it would be really nice if we weren't paying for those for the entire 2 weeks. We were just paying for them for the time we were using them. And then always in the back of our mind is security. So with that, this is the same slide Salim showed early on. This is sort of a standard EC2 instance-based architecture. We looked at this, we set it up, we tested the performance. What became quickly evident was if we've got to manage these, SSH in through the Bastion host to get on the server, to do updates, to do whatever work you needed to do, great for one site. This is a great architecture, but it's not tenable when you're talking about the number of sites we were looking to move to this architecture. So, this has everything, checks a lot of the boxes, but the maintenance was not there. And as Salim said, you can go check this out on AWS. It's very nice, works well. So then we decided let's take a look more in the serverless area. Let's see how much of this we can do truly serverless, where we're not having to log in and manage that box. And we looked at this architecture. This one came out in like July 2021. So it was after we did our proof concept, but we looked at something similar. We were in the same boat. If you get out and actually take a look at this and try to set this up, you can just take a look at the documentation. It is very complicated. And it didn't get us out of that problem of having to maintain 50 of these things, because you're still having to do a lot of configuration on this environment. So we took a step back and said, well, what if we took a serverless approach to the whole thing, the entire problem we have? So if we treated the entire infrastructure, all the parts of it, the caching, the database, the networking, the compute part, the Drupal, the web server, if we treated all that infrastructure as code, and then if we actually took that code that we had that would create the entire infrastructure and treated it as an application. So just like you would when you load up a Lambda function, you take your JavaScript code and you load it up in the Lambda function, it takes input and produces output. Well, we wanted to do the architecture to do the exact same thing. So in doing that, our infrastructure as code would actually build the entire serverless environment, the entire serverless infrastructure. And if we could do that, we would really be able to reap serverless benefits for the entire infrastructure. So it was really appealing to us. So as far as the compute options, we looked at all the usual suspects, all very good options. Red Hat OpenShift, Kubernetes managed, AWS Fargate, a little less of the orchestration features we wanted, Elastic Container Service, similar, little less of the features that we wanted. We looked at Azure AKS, but we'd already had a few things in Amazon, and we were working with some of the solutions architects at Amazon. So we kind of leaned towards the AWS EKS as far as our compute engine. And then beyond that, sort of the check boxes we knew we were going to need. We were going to need templating tools. You have to be able to use those to do the infrastructure as code. We need centralized monitoring, and setting up sort of the AWS monitoring for one site is good. It's good, but once again, when we're talking about 50 sites, it just gets really complicated very quickly. Same thing with logs and debugging. We needed centralized logs and centralized debugging, and we knew early on we needed a console, a dashboard to manage all these 50 infrastructures that were sitting out there. And that's where working with Salim and Dev Panel really came into being. And so the architecture we settled upon, this is what we call our sort of production grade serverless architecture. We're using EKS managed Kubernetes. We have an elastic load balancer to sort of distribute the load to the available nodes. We're in multiple availability zones. So we have our fault tolerance. We were using to cover sort of the normal traffic we would expect. We were using on-demand instances, but to handle spikes, we were using spot instances. And there's a huge potential savings there. If you can spin those spot instances up quickly enough to handle the traffic, you're looking at like a 90% savings on those. So those are just a great deal. And we're using serverless RDS. All the benefits of using that were there. Memcache and Elasticache, we were using AWS services for those. Elastic File System, the S3 object storage, and a CDN. CloudFront, Akamai, you definitely need a CDN mixed in there. And so our objectives, we wanted to measure the cost of migration. How much time and effort was it going to take to get these sites over, to get them up, to get them running? And document all the steps involved and get that as efficient as possible. We, of course, wanted to determine what amount of savings we were looking at. And then measure the performance of the sites. As I said, the site performance had to be there. We weren't willing to give on that. And then the auto scaling was something that we needed to verify that it would not, during spike period, cause errors, cause our websites to go down, anything like that. So we had to verify that if we were to hit it really hard, it was going to auto scale and do so gracefully. So on to the results. As far as migration times, we were looking at, to do the steps, preparation. We wanted to automate the migration as much as possible, and then do automated testing on the sites. We would manually review the log results and test results, and then come up with a no-go decision. And we were looking at a time about 1 to 2 days, and really that was very generous. We were actually looking at probably about half a day to do a site. So we were being generous on those estimates. Now, the cost savings, and this is where it gets really interesting. We set it up with equal load simulation. So we were looking at how much it would cost to handle the current loads we were seeing. To do so, we used the AWS cost estimation calculator, really nice tool. We worked directly with AWS solutions architects to make sure that we weren't missing any of the pieces here. We didn't want to get bit by missing some networking piece that was going to end up costing us, 50, 60,000. We took the estimate we came up with and doubled it just to be sure. And the other thing, this was all based on on-demand reserved pricing, and this wasn't including our, as I referred to earlier, our spot instances that we were using and the huge savings that we could get there. So this is sort of a generous, very high estimate. And then to back this up, while we were doing our testing, we actually looked at the costs incurred. And we came back and were able to verify this number that, yes, that's what we were seeing from the actual, what we had to pay for to do the testing. And all in all, we came up with about a 75% cost reduction. So that was huge. That was, really eye-opening. And as far as the performance, we did a lot of load testing on the architecture. Everything was targeted back to the origin. So we were not relying on a CDN to handle any of the traffic or anything like that. Everything went back to the Kubernetes clusters. We stress tested the entire architecture. We did it both cold, so we tested how it would respond to the 0 to 60 miles an hour. And then we tested it under load. How would it go from 60 miles an hour to 120? We used a bunch of different stress testing tools, JMeter, Siege, and AWS has a nice distributed load testing tool. You used to be able to run JMeter from within that tool, so it would spin up a huge amount of nodes and run JMeter. I don't think it does that anymore. Salim was saying he saw that they had removed that functionality, but it's a great tool if you ever need to do load testing. And we put a link down at the bottom. But we were able to simulate loads the same as our production site. And to verify the performance, we ran tests while the infrastructure was under load. We used a bunch of different tools to do this: web page tests, Lighthouse, YSlow, and the results were comparable to our current production environment, if not a little bit better. And in this case, you'll see that we did get 1F. We knew we were going to get that because we didn't have our static content cached. That was just something unknown. So this result may have even been a little bit better, but we were very happy with the results we got. And then the auto scaling. This was another piece we needed to ensure that was actually going to work properly. So once again, stress tested the entire architecture, and we monitored the clusters, and you were able to see it bringing on nodes as we needed them. And then we'd hit it with a spike. We would up the traffic 30% and just watch it. It would gracefully handle the loads, even under those extreme spikes. You know, we're a news agency, so you never know what's going to happen in the news. It's going to cause a huge load on your web servers, on your infrastructure. So in the end, was it worth it? The pros, you know, one outside of this, it was a great learning experience. I recommend looking into this and using, you know, AWS or Azure resources to jumpstart you on this. But besides that, we saw great performance. We were really pleased with the results we got from the performance testing. The auto scaling is awesome. You know, it takes out that when your servers are sitting, you're paying for servers that are sitting idle. Well, we weren't paying for servers sitting idle. They were going away. The architecture was actually scaling back, and we were saving money there. And the end result was really a huge projected cost savings. Cons, it can be difficult to initially set up. Even if you try the quick starts, like the AWS quick starts and everything, it can be difficult. It can be tricky. Once you get it set up, you have that infrastructure as code. You have those templates. You have everything you need. From there on out, it's really nice. But that initial setup can be kind of difficult. And then you need other tools to manage this, especially if you're doing a couple sites, you're probably okay. But if you're doing more than a few, you really want tools to help you manage it. And the question is, do you build or do you buy? You know, you do need a dashboard. We used DevPanel for our proof concept, and we're really happy with what we were able to do with it. And then you're going to need ongoing support. You're talking about 24/7 support. Do you have the technical expertise that is familiar with serverless, that is familiar with these sort of infrastructure components? So you could also need ongoing support. But in the end, it was very eye-opening and definitely worth it. And Salim, did you have anything you want to add?
No, I think you covered all the good points there, all the major points. So thank you. So we're open for questions. I think, and we have other slides on how the infrastructure works. And there's all the backup slides. We didn't know how much time we would have left, so we have a bunch of slides on the infrastructure, on how that works. But if there's any questions, I see there's one question that Eric asked. how much traffic were you expecting with static websites where traffic would require scaling? In this case, I don't think we were using static websites. I mean, your websites changed so much
Yeah.
with all the news coming in and out. There
Yeah.
wasn't any need for any static websites. So um,
We were researching the ability to, how would we do static sites?
yeah, that was a big thing. There was a big push on looking at static sites and trying to see if we could do static sites, but we never got to that point. I think we ended up, going to the point where we were using Varnish and we just said we would use Varnish and CDN, and that would be it. Because of the volatility of the content that changes
Yeah.
on the news sites. So the other question is, did you actually implement this? Was your small internal team able to support this? That's a good question. So I'm going to let you take that.
Yeah. So full disclosure, we were never able to implement this. I'm not sure if management was
In production, yeah.
in production. No, we were not. And in fact, the decision was made to actually move away from Drupal. So I don't know if they were turned off by the high price that we were paying at the time, but uh, yeah, never able to actually implement it. But the proof of concept was there. The results were there, and we were very proud of the work. And I highly recommend looking into it. In our case, it didn't work out.
There's
So
a good question in the Q&A. Did you have to get an ATO, and did AWS provide those?
We did not have to get an ATO to do the proof of concept.
and how many people in your team?
Internal team, 4 people. That's why we reached out to Salim and Dev Panel to help us out there. So
Yeah, there's
very
quite.
small team.
Yeah, is this similar to some Amazy offers, something Amazy offers, except they provide the support? Yeah, we provided the support as well. I think this is different because they wanted to run this. The difference between, I think, DevPanel and some of the other providers is it's a good point. We don't. We actually run all the services in our client's account. So Joel and team and VOA wanted to run everything in their account so that they could pay AWS directly. And they're not paying. They wouldn't be paying us for any of the AWS bill. We're not sitting in the middle. So they're just paying us for the control panel and for the support. And that's why they ended up. That's why we ended up talking. So
Yeah, and that made doing the proof of concept a lot easier because we were doing it using our resources in our accounts, and we were sort of overseeing that.
yeah. So another question from Kelly: are you looking to do any changes to help reduce the overall cost, uh, improvement management, or provide any more efficiency in site development? I'm going to let you take that, Joel.
Right now for the current project?
Yeah, I think they've changed over to like a
Yeah.
different CMS, their old CMS. Uh, from what I understood, they were frustrated by the cost of hosting that they were paying for the 4 websites, and the frustration level was so high that the upper level management there just got turned off of Drupal and just decided. And this was while we were doing this project
Yeah,
at some
we
higher
were
level.
tasked with doing this just to see
Yeah.
if we could provide the same service at a lower, reduced budget. But
Yeah, the powers that be. Is what CMS did you decide to move to, and to that would save money? Yeah, do you know, like, what was the
Yeah, it's
whatever's the legacy CMS was,
the
right? Like,
legacy, yes.
yeah,
Pangea. So it was what was being used before we moved to Drupal.
yeah,
But that's a short term. Long term is to find a new CMS.
yeah. Okay, so I'm gonna go on to the. We still have a little bit of time, so I'm just gonna go on to the some of the extra slides that we had and talk about how the infrastructure works, and oh, there's another question. What is the worst support issue? Um, I'm not. Do you have any support issues right now, or what were your anticipated support issues?
Our anticipated supports, a small amount of people on the team, mainly skill sets. You know, you need people that are essentially solutions architects with a lot of technical experience. So those were mainly our support issues.
Yeah, and I think if you're going to implement a solution like this, this is something that we had implemented at other companies. So if you're going to implement a solution like this internally on your own infrastructure, you'd want to have whoever the vendor is, you know, have support from them. So that was basically, that's what it boiled down to, is you want to have ongoing support from whoever your partner is. You want to have implementation support. You want to have ongoing support from them. So yeah. So I'm going to walk through this. This is the infrastructure that we ended up implementing, and these are the backend services, the managed services. But from the EKS, from the Elastic Kubernetes services from Amazon, EKS manages all the nodes, which are the servers, and it adds and removes those servers as needed using the cluster manager. And these servers are managed across different availability zones. So if one availability zone or one data center goes out, the other data center is still available to serve out your website. And then in Kubernetes, you have these containers, or we call them pods because they're multiple containers running together. These containers run on top of these servers, and these containers are also managed by EKS, which is your Kubernetes service. And so the containers are running on top of the servers managed by Kubernetes. And then the ELB, again, it's a managed service, Elastic Load Balancer, that distributes the load evenly across all your resources. And as your load increases, right, the EKS, the Kubernetes will spawn out new pods and across different zones. So you've got multiple pods getting rolled out across different zones, and with those pods, to handle the load of those pods, to handle the capacity, we're automatically going out there and getting spot instances, and these are servers that we get at 90% discount. So this is something that VOA gets the discount for directly from Amazon, and these are underlying servers that the pods are running on, and these servers can come and go as needed. This is extra capacity. These are extra servers that Amazon has, and they're just giving it away for 90% off. So we can provision these servers and run the pods for the extra load. And as the load goes away, Kubernetes will release the pods that the site is running on, and it will automatically release the spot instances as well. So you're not paying for those on an ongoing basis. You are paying for what you're paying for is the reserved nodes that the load runs on, the minimum capacity that you need to run your website on all the time. There's also managed services. These are considered serverless as well. And these are managed services like RDS, serverless RDS. And this is provided by Amazon as a serverless service to you. So you're not managing any of the servers. They're just providing resources to you, and they scale it up and down as needed. So EFS is a file service, Elastic File Service. S3 is object storage, Elasticsearch, and Elasticache. And then the CDN is the CloudFront. In VOA's case, they were using Akamai, I believe, right?
Yeah, Akamai.
Yeah. So we didn't end up using CDN, but in our infrastructure, this is the base that comes with it. There's other question here. Did you have vendor support, or did the 4 people on your team do the support for everything? To clarify, were you running this yourself on AWS, or and not using a vendor? From like, we were still in the POC state, so this was still a proof of concept. The idea was that they would be running it themselves. Joel has enough background in AWS to manage this, and we would be the second level support for them. So that was the plan going forward. Joel, you want to step in and add to that?
Yeah, that was to get the team as small as possible. We did have a contractor that was developing our Drupal site. We were working with them as well, but we're still talking a very small team.
Yeah, and right, they were going to be the first line of support for you guys, and then we were going to be the second line of support to you and to them. So yeah, that was good question, Joseph. Okay. Right. So here's our contact information. If you have questions, you need any of the scripts to set up infrastructure or anything, let us know. Question: why did you choose Akamai instead of CloudFront?
Decision was made way before I got there.
Yeah, it was handed to us. So
yes, that's what we had to work with at the time.
Yeah, it was not our choice. So.
It was the least resistance.
Yeah, the path of least resistance. It was like, this is what you have. This is what you got to use. So.
Yep.
And any other questions? These are great questions, by the way. So yeah, any other questions? We have a few minutes left here. So thank you, guys. Thank you all. Okay. So let's see. The cost savings estimate didn't seem to include the second tier support. If that was included, is there still a savings? That's a good question. We had doubled. I would say maybe even more than doubled the cost estimate, because we did not include any of the spot instances, and we took the cost estimate and we doubled it. It did not include support, but the original hosting fees did not include that support either. So from a vendor perspective, your prime contractor support fees were not included in that original hosting, and our fees were not included in that. So yeah, that's a good point. We charge, our support fees are a small percentage of the AWS fees. So that's how we charge for support. But that's a good question. Yeah. Joel, you want to add to that?
No, I think that covers it.
Okay. Good question, Joseph. Anything else? Okay, then I think we're at time. Thank you, everyone.
Cool. Thanks.
Thank you, Salim and Joel. Appreciate it. That pretty much concludes our day for Drupal GovCon. Stay tuned to tomorrow. We have more sessions. Check out the schedule, and I'll see everyone tomorrow.
Yeah. Thank you, Jason, for moderating. Yeah.
Yep. Thank you, guys.
Thank you.
Take care. Bye.